In this video, we are looking to simplify rational expressions. And we'll start with simple ones. We'll get to ones where you have to factor. And in the end, we'll look at some complex rational expressions. Okay, so a rational expression is the quotient of two polynomials. So here's some examples where you have this expression over another expression. This one here would be a complex one, and we'll look at something like that later. And what we want to do in each of these is to try and simplify them if we can. For this one, we'll try and factor the top, factor the bottom, and then see if there's a common factor of one that we can remove. When you're looking at any complex or any rational expression, actually, it doesn't have to be complex, if you have a variable that's in the denominator, you have to worry about what numbers you can put in. So there's always a caveat or a restriction for that particular expression. And the restriction is that you can't have a zero in the denominator. So you can't result in a zero in the denominator. So for this particular expression, you can say, yeah, that expression looks fine as long as you don't have the number 0 in for x. Pick any other number for x, all is good, that expression will function fine. But if you put a 0 in there, not going to work. In this one, again, you want a 0 at the end, or that's what you don't want. So in this case here, if I put a 0 in there, 0 plus 3 is 3, 3 on the bottom is fine. But if I put in a negative 3 plus 3 is 0, can't have that. So this expression is defined for any value of x as long as you don't put in a negative 3. So the domain of this, if they're saying what is the domain, then they're saying, okay, what letters will actually work? Then you'd say something like this. You can put in any x's you want as long as x is not equal to negative 3. That's what you'd say for this one. If you wanted to write it in interval notation, you'd do it something like this, and I like to write it on a number line first. There's 0, here's negative 3 there. So I can use any number going up to there, but I can't use negative 3. And I can use any number going this way. So I can say, well, use any number from negative infinity all the way up to negative 3, not including negative 3. That's what a curly bracket means. And any number from negative 3 all the way to positive infinity, those all will work, and you see a union of those two. In this case, where it can't be just one number, a little easier to write it in set notation. Okay, here's a couple of questions where they want us to find the domain, and try them and see how you do. For this first question, there's no x's on the bottom, so you can plug in any number you want for x at all. There's no restrictions. In set notation, you'd say something like this: all your x's, as long as x is an element of the real numbers, life is good. In interval notation, you'd say from negative infinity to positive infinity, plug in anything you want. Okay, this next question, you have, maybe I should simplify it below, x cubed minus x squared minus 5x plus 6 over, on the bottom I can factor that, so it'd be x plus 7, x minus 4. So the numbers that I don't want, that can't be part of the domain are negative 7 and a positive 4. So in set notation, you'd say something, use all the x's as long as x is not equal to negative 7 and x is not equal to a positive 4. In interval notation, that'll be a little bit tougher. So negative 7 doesn't work and positive 4 doesn't work. So everything from there up to here is okay. So you can say something like from negative infinity all the way to negative 7, not including negative 7. Life is good. Then from negative 7 to positive 4, it works too. Negative 7 to positive 4, not including either of those. And then from 4 up for forever. So from 4 to infinity, that works as well. Again, curly brackets to say it doesn't include that. And then you'd say the union of both of those. Okay, try this one. And then press pause and then press play. So on the bottom, you can factor that to x minus 3, x plus 3. On the top, it looks like I can factor that too. I think it's x plus 3, x minus 1. Now in this case here, the x plus 3's cancel, so I can simplify that expression to just x minus 1 over x minus 3. So there won't be a restriction of having a negative 3 in there. My only restriction will be this one right there. So in set notation, all the x's, as long as x is not equal to a positive 3, that's the number I can't put in there. In interval notation, you would say from negative infinity to positive 3 is good, and from 3 to positive infinity is good, and it's a union of those two intervals. Okay, like I just did in the question before, if I want to simplify a rational expression, I want to factor it. And when you factor it, you're looking to see if you can remove a factor of 1. So for this top one, I can factor that. I think I just did that one. Or y plus 7 and y minus 3. On the bottom, I think that's y minus 3 and y minus 3. You can see why factoring is an important thing. Okay, here's a factor of 1 right there. The same thing on top and bottom. When you divide those, it becomes 1, so I can remove that factor of 1. So my answer, or my simplification of that, will be y plus 7 over y minus 3. You try this one. Press pause, then play. Okay, let's factor. So the top looks like I can factor a 3 out. That'll leave me with x squared plus 2x minus 1. Is that right? Oh no, 3x squared plus 2x minus 1. Yep. And then on the bottom, I can factor a 12 out. That leaves me with x squared minus 1. Now on the top, I wonder if I can factor that. I think so. So 3x and x. And I'm thinking a 1 here, a positive 1, and a minus 1. Let's just check. 3x squared plus 3x minus x is 2x, and a minus 1. Yeah, that factors properly. Over 12, and then this is a difference of squares. So it's x minus 1, x plus 1. So these are a factor of 1, they go away. And then the 12, 3 goes into 12 4 times. So I could do something like this. I could say 3, and then 3x minus 1. And on the bottom, I'd have 3 times 4 times x minus 1. Is that right? Yep. And the 3's cancel. So my final answer would be 3x minus 1 over 4 times x minus 1. Okay, that's a good one. Okay, we can also divide rational expressions. Dividing fractions is the same as, or what you want to do is multiply it by the reciprocal. So I'm going to do 2 steps at once. I'm going to factor them, and I'm going to change the divide to multiply and invert the second fraction. The first one on the top here, I can take a common factor of y out. The bottom is y minus 3, y plus 3. Again, it's very good to be up on your game for factoring. Multiplied by, so I'm going to take this one, and it's going to move up to the top. So I'll focus on that. It'll be y plus 7, y minus 3. I like it when they have lots of factoring of the same thing. And then this one has to go on the bottom. So that'll be, when you factor it, y plus 7, y minus 2, I think. Yep, that looks good. Okay, now since it's multiply, anything's fair game on the top with anything on the bottom. So I can cancel this and this. That's a factor of 1. Here's a y minus 3, and there's a y minus 3. What else? Oh, y plus 7, Whoops, that was a eraser. Y plus 7 and y plus 7 go. So it looks like on the top all I have left is a y, and on the bottom all I have left is a y minus 2. So that would be the simplification of that. Go ahead and try this one. Okay, I'm going to do the same thing. I'm going to try and factor and flip at the same time. So 3 times x plus 4 over 2 times x minus 4 times, on the top then I have x minus 4 squared. I'm just going to write 2 of them out. And on the bottom I'll have x plus 4 squared, or 2 of them. Okay, now looking to cancel anything that's the same. X minus 4, that's a factor of 1 I can take out. Here's an x plus 4, I can take those out. So in the end, I'll be left with 3 times x minus 4 over 2 times x plus 4. Done. You can leave it at this stage right there. If you wanted to multiply it back through, that would be fine. And typically, if they say simplify, they do want you to get rid of brackets. But leaving the question like this, for me, is perfect. Okay, this, you'd get 100% for both of those. Okay, now adding and subtracting fractions. Oh, now these ones, when you add and subtract fractions, a little bit tougher because you have to get a common denominator and you have to deal with that. Let me show you a couple of examples. This first one, it already has a common denominator. If it has a common denominator, I can just write one denominator in the bottom. That minus sign there, though, you have to be careful because this x minus 2 is over x plus 3, and you're subtracting all of that, not just the x. So the way I would write it would be, and you could use brackets here, 4x plus 5 minus x minus 2. And maybe that'll help you so you don't mess up the negative sign there. So then I would drop the brackets. In the first bracket it doesn't matter, but the next one does. So it'd be minus x plus 2 all over x plus 3. Collecting like terms, I'd get 3x plus 7 over x plus 3 done. That's a nice easy one because the denominator was the same. Let's try one where it pushes us a little bit more. Okay, the denominators aren't the same, so I need to factor them. So let's write the first one, and let's try and factor it. I'm thinking 3x and x, and then maybe, oh, it has to be 2 and 4. Maybe a 2 and a 4, like that. And the bigger number has to be negative, so this would be negative, this would be positive. Let me check. 3x squared minus 6x plus 4. Yeah, that gives me minus 2. And a minus 8. Perfect. Minus 7 over, okay, more factoring. 3x, x. So I've got to get 4. So maybe a 1 here and a 4 there. And the bigger one has to be positive. So I'll be positive. This is negative. Let me check. 3x squared minus 3x plus 4x. Yeah, that's x. Yeah, that's correct. Again, practicing that factoring and getting so that you're good at factoring, a key thing here. Okay, so now what I'm looking for is the lowest common denominator. So the lowest common denominator, I need to have every factor the most number of times it occurs in any one factorization. So I have a 3x plus 4, and here's 1, so I need one of them. I need an x minus 2. Here's 1, there's none over here, so 1 is good. And then I need an x minus 1. So that's my lowest common denominator. So this first expression here, I'm going to give myself a bit more room, needs to have what it originally has. And then I need to look at the lowest common denominator and say what's missing. I don't have an x minus 1. So I need to include an x minus 1 here, and I need to include 1 on the top. Okay, minus, let's do the same thing over here. I have 7 over 3x plus 4x minus 1. Okay, that's what I have. And I look up here, it looks like I'm missing an x minus 2. So I need to include that there and there. Okay, so now I have a common denominator. Let me write it. 3x plus 4, x minus 2, x minus 1. And then on the top I have 9x plus 2. Maybe I could have done a little bit of work here, but... And then I have minus 7 times x minus 2. Do you see where we might get into trouble here with this one? It's that dirty, rotten, filthy, stinking negative. So let me FOIL the first one. 9x squared minus 9x plus 2x minus 2. And then this one, the distributive property. So it'll be minus 7x plus 14. And that's where a lot of students mess up. Over the common denominator. X minus 2, x minus 1. Good. Collecting like terms on the top, I only have one x squared thing, so 9x squared. In terms of x's, I've got minus 9x plus 2, that'd be a minus 7, and another minus 7 would be a minus 14x. And then for numbers, I just have this and this. Minus 2 plus 14 would be a positive 12 over the lowest common denominator. Now, the last thing I would do is try and maybe factor this. But 9 times 12 is 108. Things that multiply to 108 and add to 14. I don't think there are any. You can try some, but I don't think there are any. So, that would be my final answer. That would be the difference of those two expressions. All right, you try one. Press pause, then press play, see how you do. Okay, first thing hopefully you're doing is factoring. So you have 3y over y minus 2y minus 5 minus 2y over y minus 5 y minus 3. I think those are factored correctly. So my lowest common denominator will be an y minus 2, y minus 5, and a y minus 3. So I'll need to include all three of those. So the first one, I have a 3y over y minus 2, y minus 5, y minus 3. Oh, let me put that in another color. Y minus 3, because that's different. Plus 2y. Oh, why did I get a plus? Minus 2y over y minus 5, y minus 3, and the thing that's different is a y minus 2. Y minus 2. Good. Now you have a common denominator. I can write it. Y minus 2, y minus 5, y minus 3. And then on the top, I'm just going to go ahead and multiply those. So it'll be 3y squared minus 9y. Careful with this one because it's a minus 2 times each of those. So it'll be a minus 2y squared plus 4y. Simplifying, I'll get just 1y squared minus 5y all over y minus 2, y minus 5, y minus 3. At this point, I'm thinking, I've done enough work. That's a good question. But I'm not quite done. You always want to try and factor and see if you can remove another factor of 1. On that top, you can factor out a y. To leave this, you see where I'm headed? Y minus 2, y minus 5, y minus 3. The y minus 5's cancel. So my answer will just be a y over y minus 2, y minus 3. Tough questions. Yeah, very tough question. Right, here's a question where we're asked to simplify a complex rational expression. Complex are ones where you have fractions over fractions. To simplify, it involves changing the expression so only you have one fraction. So in the end, I want this to be some a's and b's over some a's and b's, but I don't want extra fractions in there. So that's where I'm headed. Now, to simplify a complex rational expression a number of different ways, the way I've found is easiest is to multiply every term in the expression by the lowest common denominator. So let's take a look at this denominator, this one, and this one, and this one. Lowest common denominator will be the expression that includes all factors, or each factor, the most number of times it occurs. So I see a's and I see b's. The most number of a's I see in any one factorization is 3. So I need an a cubed. For b, it's the same thing, so b cubed. So this will be my lowest common denominator. So I'll take the first, the top expression there, and the bottom, and I'm going to multiply each of them by the lowest common denominator. And that is a cubed, b cubed, and you could say over 1 if you want. So a cubed, b cubed over 1. So on this first one, when I multiply, I'm going to get an a squared and b cubed. I think that's right. And on the next one, I'm going to have an a cubed and a b squared over the next one. And what I'm doing here is I'm canceling. So I'm looking at this multiplied by that. So in that first multiplication, this times that, the a cubes will cancel, so I'll be left with b cubed. And then if I multiply the same thing by the b cubed, the b cubes will cancel, so I'll be left with a cubed. Okay, now I think that is right so far. Now, on the top, I can probably factor something out. I think I can factor an a squared b squared out, leaving me with an a, no a's there, a b plus an a. Okay, all over, I'm just going to change the order there, a cubed plus b cubed. Okay, feeling pretty good there, although this looks to be a sum of cubes, and there's a formula I can use to simplify that. Okay, so the formula, I'll just write it down here. If you have a cubed plus b cubed, that's equal to a plus b times a squared minus ab plus b squared. So that's exactly what I have there, so I can write that. A plus b times a squared minus ab plus b squared. So that's what this bottom factor is at. On the top I have a squared b squared and b plus a, or that's commutative, so I can write it as a plus b. You see what's happening now? I can cancel this and this, so my final answer should be a squared b squared over a squared minus ab plus b squared. Okay, hopefully that helps on that question. Okay, you try this one. I'm looking at it and I see a common denominator is going to be xy. So I'm going to take x over y minus y over x, and I'm going to multiply that by xy over 1. And then my 1 over y plus 1 over x, I'm multiplying that by xy over 1. Now careful, when you multiply this by this, something will cancel, like on that first one, the y's will cancel. I'll just write it over here. I'm doing xy times xy. So the y's cancel, so you're left with an x times x, which is just x squared. So that's all what I have on that first one. Now I'll multiply this by this, And there the x's cancel, but the y's don't. So I'll have x squared minus y squared. On the bottom, the y, if I multiply this times this, the y's cancel, I'll just be left with an x. Plus, this one, the x's will cancel, I'll just be left with a y. Feeling very good at that point. Always, though, try and factor. That top thing looks like a difference of squares to me. Again, hopefully you see where this is going. The x plus y's cancel. I'm left with x minus y. Okay, so hopefully that has helped you. We've looked at in this video at defining rational expressions. We've simplified them. We've looked at the domain of them. So what numbers are allowed and what numbers are not allowed. We've also divided, multiplied, added and subtracted, and we've simplified complex rational expressions. So try the video quiz, try the homework and the other quiz. If you have questions, as always, give me a holler.